Sabine Hossenfelder is a part-time science YouTuber, part-time physicist, prolific author, and fabulous dancer.
It's taken me some time because my brain is really small, but now I understand some people can explain it all.
One thing is sure about Sabine: she is not afraid of controversies. Her rebellious nature often invites them, and it is fair to say she is currently in one. This time, however, the controversy is different.
I don't trust science and I don't trust scientists.
Sabine, a scientist, is now facing accusations of promoting anti-science narratives wrapped in anti-establishment rhetoric, with some even branding her a hypocrite. In her videos, Dr. Hossenfelder appears as rebellious or even annoyed.
Most of what physicists do in the foundations of physics today is pseudoscience. It's paper production with no scientific merit that teaches us nothing.
But when I attended her public lecture in Munich, I had a different impression. She was genuinely friendly and modest. So what's going on? In this video, we are going to explore exactly that. In Dr. Hossenfelder's life, the first eye-opening event towards academia appears to have occurred as early as her master's education. Sabine's perception of academia, as she herself put it, was hopelessly naive.
I don't come from an academic background. I come from a family of teachers and accountants and post office workers.
In her master's degree, Sabine worked with Walter Greiner on black holes. Greiner, who recently passed away, was a respectable physicist well known in the community for his series of books on theoretical physics. I myself have used his book, Field Quantization, to learn about quantum field theory, and, I must admit, it is really good. In a 2018 blog post, Sabine revealed that her professor Greiner fired her from her master's project. In a later video, she explains the reason.
The next problem was that the head of the institute made a lot of money selling textbooks. He wrote very little of these textbooks himself. Rather, he gave assignments for parts of the books to students and postdocs, which is why, in case you've ever wondered, these textbooks are so discontinuous and partly repetitive. He expected me to also work for him, to which I said no. I was then ordered into his office, in which he gave me a very angry speech, according to which I wasn't loyal to all the other students who did their part. I told him that I was under no obligation to work for him and didn't care what the rest of the students were thinking. He got angry, I laughed at him, he started shouting that I was fired and physically shoved me out of his tent. I'm not just telling you this because it's entertaining. It was also a rather rude awakening. It made me realize that this institute wasn't about knowledge discovery, it was about money making. And the more I saw of academia, the more I realized it wasn't just this particular institute and this particular professor.
It must have been disappointing to learn that such a respected academician could be so petty. After a string of postdocs requiring moving and living far from her husband, she decided she needed to return to Germany with her children.
I had moved half around the world because that's standard for postdocs. It's just expected of you. And at some point you just accept the constant moving as normal because the only people you know also do it. It's incredibly hostile to personal life, detrimental to mental health, and women suffer from it more because our reproductive reality is that we need to start families.
This constant need to move for jobs and chase grant funding appears to have left her disappointed with academia. But there was something else as well. She did not understand why otherwise intelligent people were dedicating so much effort to something that, in her view, was clearly not working. Here, we are talking about string theory. Massive physics breakthroughs from relativity and quantum mechanics to particle physics eventually ended in 1973 with the completion of the Standard Model. The only obvious thing left was to unify quantum mechanics with gravity. During the 80s and 90s, string theory emerged as a possible theory of everything, capable of unifying all fundamental forces, including gravity.
Where we have vibrating strings moving in 10-dimensional hyperspace.
String theory was hyped both within the physics community and among the general public. Every talented young physics student was expected to join it, and the narrative was such that if you are not doing string theory, you are dumb. However, there was a small but vocal group who was skeptical of this. In 2006, both Lee Simmelin and Peter Voigt wrote books criticizing the string theory. Their top criticisms were as follows. The theory lacked any experimental evidence.
Getting this nonsense past peer review was to invent reasons for why this supposed evidence for string theory had not been seen so far, but would show up in the next experiment. It's always the next experiment that'll find.
Secondly, it required artifacts like extra dimension and supersymmetry. Thirdly, there was the sociological problem. As a researcher, if you wanted to get funding, you had to do string theory.
Putting string theory in a grant proposal became a way to get your research funded. I myself wrote my PhD thesis on how to test those large extra dimensions of string theory at the LHC.
This heated debate of 2006 between advocates and critics of string theory is referred to as the String Wars. Around this time, Sabine began her blogging journey, aligning herself with the critics of string theory. The reaction from string theorists was, to put it mildly, unprofessional.
I don't think anyone would call Lee Smolin a crackpot.
You want to take a vote on that?
It might be fair to say that Sabine's side emerged victorious in the string war. The aftermath of this loss was that string theory faced increased scrutiny from both the physics community and the general public. Even some senior string theorists acknowledged that the ultimate goal of string theory remains unfulfilled.
So I can tell you with certainty, string theory with a capital S, the precise mathematical structure, which, as I said, mathematicians win prizes for. Incidentally, no physicist has ever won a big prize for string theory. I can tell you with absolute certainty that it is not the real world that we live in. So what do we make out of that? I don't know. We need to expand the theory. We need to generalize it a little bit. And in fact, I can say a little more, that no known version of it, no precise known version of it exists in de Sitter space. We live in de Sitter space.
Sabine and her gang go so far as to declare string theory a dead field.
Putting string theory in a grant proposal became a way to get your research funded. I myself wrote my PhD thesis on how to test those large extra dimensions of string theory at the LHC. The result of the string wars and the following failure of the LHC to see even a shred of evidence in support of it was that the branch of string theory, which contained the last remains of the original idea to find theory of everything, basically died off.
In my view, the real damage is that young people are no longer drawn to string theory. This, eventually, will likely lead to its end. Back to Sabine, she started an interesting initiative called Talk to a Scientist, where, for a fee of $50, people could ask anything about physics. Eventually, Dr. Sabine Hossenfelder shifted from blogging to YouTube, first with her dance videos and then with science content. Her videos, sometimes provocative, gradually picked attention and propelled her to fame. She's now a professional YouTuber with a team behind her, putting out videos almost every day. Let's first discuss the good sides of her videos. Sabine Hossenfelder is an excellent educator when it comes to explaining well-understood subjects that have broad consensus. She criticizes oversimplified physics phenomena that other physics channels do not care to explain extensively. Many of her criticisms regarding the current status of academia are totally valid, and people in academia resonate with them. She often criticizes that no physics achievements have been made in the last 40 years. At least in the foundations of physics, it is not just an opinion. It is a fact. It is also quite satisfying to see her stand up against the toxic behavior exhibited by some string theorists. I mean, just pause and see this bizarre Twitter thread of a string theorist called Strinking 42069. However, recently, she has gotten into arguments with Professor Day for her so-called anti-science videos.
This
Thumbnails that say, "I don't trust scientists." That's the problem with Sabine. Incredibly unprofessional, damaging clickbait thumbnails like this. And statements like this.
Most of academic research that your taxes pay for is almost certainly bullshit.
That's a ridiculous and totally indefensible statement that
The kind of science deniers Professor Dave is talking about include flat earthers, anti-vaxxers, and climate change deniers.
I personally began to notice this when I observed that a fair amount of science deniers would commonly reference her. That's a red flag.
They can cause significant harm on both individual and societal levels as they vote and influence decisions. I mean, just look at anti-vaccine movements during the pandemic. Others on Reddit share similar concerns. But why do science deniers follow her videos? Professor Dave explains the reason as follows.
As it turns out, it is a firm anti-establishment sentiment, and in particular anti-academia sentiment, which, as any viewer of my debunks will recall, I consistently describe as the single characteristic that unites all science. To paint with such a broad brush and brand the entirety of academia this way is just dishonest, tasteless, and quite frankly amounts to nothing but sour grapes.
Some think that Sabine's comment on academia might be too harsh, and the situation outside academia is not good either. Others complain that she has recently been publishing too many unpolished, poorly researched videos and is thus falling into the classic social media victim. In my opinion, the situation worsens when she talks on a topic where people lack consensus and puts her views as the only truly good one. For example, consider her recently published videos on the black hole information paradox, where she complains that the problem is not worth researching. In 1975, Hawking showed that in the context of black holes, combining general relativity with quantum mechanics leads to information loss. This is a paradox, as information preservation is a fundamental principle in physics. But this is not necessarily bad news. Paradoxes coming from the conflict of established principles are the major source of scientific progress. The ultraviolet catastrophe, for example, led to the development of quantum mechanics, while the paradox surrounding the speed of light in the ether paved the way for relativity. In fact, Hawking's information paradox is the biggest hint we have in solving the problem of quantum gravity. There are multiple approaches, no consensus, and the problem remains wide open. Yet, Sabine thinks the problem is uninteresting.
If we did, it wouldn't matter because it won't be useful for anything. Really, the reason I'm telling you about this is that I used to think this was interesting because solving this problem was supposed to teach us.
Even her own viewers are highly skeptical of this. One viewer commented that he is dubious of statements declaring that we'll never know the answer to a given question, or that such an answer would never be useful for anything. The other viewer was surprised that how a physicist couldn't care what would happen at the black hole. After these criticisms, Sabine uploaded another video clarifying the situation.
It's not maths. Unfortunately, we can't make the measurement. It's because the radiation that comes out of the black holes that we know to exist is far too weak. Even if we could measure it, it'd take 10 to the 100 years or so until they've radiated away. Not 10 to 100 years, 10 to the power of 100.
Basically, her argument is that observing Hawking radiation is impossible in the near future. But that is just bad science. Muck once told Boltzmann that atoms would never be observed and that he should give up on atoms. Yet atoms have become a cornerstone of modern science. Indeed, direct observation of Hawking radiation from massive black holes is unlikely. Hawking himself recognized this and proposed that tiny black holes formed in the early universe could produce detectable effects. In fact, these primordial black holes have been suggested as potential dark matter candidates and, who knows, might even be detected in the future. In any case, the real issue isn't whether Hawking radiation will be measured. It's her outright claim that it will never be measured. For a very bad reason, she dismisses the biggest clue we have towards solving quantum gravity.
Do black holes destroy information? This was supposedly a huge mystery that physicists wanted to solve to understand the universe with big implications and so on. Or so popular science writers wanted you to think. And then the big mystery just fizzled away. Whatever happened?
It didn't fizzle away. What happened is that even after she left the field is highly active, with significant breakthroughs occurring in recent years. Her favoured approach, that a back reaction at the black hole horizon could resolve the problem, has since been shown to be mathematically incorrect. Sabine is often accused of committing the Mott and Bailey fallacy in her arguments. In this fallacy, one makes a controversial but bold position called Bailey. But, when challenged, they retreat to a more defensible but less ambitious position, Mott. This tactic can mislead audiences, remove trust, and confuse the speaker's true position. An example of this fallacy looks like this. Suppose a speaker claims, "The government should ban all fast food restaurants because they are causing a public health crisis." This is Bailey. When challenged, they retreat to a more reasonable and defensible position, Motter, saying, "We should implement stricter regulations on the food industry." Clearly, this creates lots of confusion on the speaker's true position. In the case of the black hole paradox, Bailey is the sweeping statement that black hole information loss is a fake unsolvable problem. However, when pressed on this, she retreats to the Mott, arguing, "Oh, using this specific method, it is impossible to detect Hawking radiation so that the problem will always remain unsolved." Sabine commits these kinds of fallacies also in her critiques of string theory and fundamental physics. Sabine has been exposed multiple times within the physics community. She published a video based on the paper by Roy Kerr that Roger Penrose's Nobel Prize-winning calculations are mathematically wrong.
Penrose proof draws wrong conclusions from this affine parameter. If the affine parameter ends, that doesn't mean that the curves end at any finite time, because those are two different things.
That Roger Penrose's Nobel Prize-winning calculations are mathematically wrong. Penrose later refuted this claim.
That's highly misleading.
This part is highly misleading.
I mean, a null geodesic, if its affine parameter stops, it stops. There is no way of continuing a null geodesic and having its affine parameter stopping and then something starting up. I mean, it doesn't make sense. So if you use ordinary time, it doesn't do any good to you at all, because it becomes zero when you don't want it to be zero. Whereas the affine parameter remains finite.
This weird interaction between Sabine and Roger Penrose shows how far off Sabine can sometimes be. Indirectly, Sabine claimed that Penrose's Nobel Prize might have been wrongfully awarded. It might very well be the case that Penrose is wrong. However, Sabine is a science communicator with over 1 million regular monthly viewers. And with that kind of viewership, she does have a responsibility to do some fact-check before making such claims. To be fair, she is a superdeterminist, so she really has no choice but to behave this way. We are talking about her controversial position in the foundation of quantum mechanics, called superdeterminism. Superdeterminism explains quantum randomness by denying statistical independence.
About the possible values of the hidden variables. Think about the hidden variables as labels for the possible paths that the particle could take. Say the labels 1 to 3 go to the left slit and the labels 4, 5, 6 go to the right slit and the labels 7 to 12 go through both. The particle really has one of those hidden variables, but we don't know which. Then, if we measure the particles at the left slit, that simply tells us that the hidden variable was in the 1 to 3 batch. If we measure it right, it was in the 4, 5, 6 batch. If we measure it on the screen, it was in the 7 to 12 batch. No mystery, no instantaneous collapse, no non-locality. But it means that the particle's path depends on what measurement will take place, because the particles must have known already when they got on the way whether to pick one of the two slits or go through both. This is just what observations tell us. And that's what superdeterminism is. Now, you may say, well, drawing lines on YouTube isn't proper science, and I would agree. If you'd rather see equations, you're most welcome to look at my paper.
Instead of reading her papers, let's see what Tim Maudlin, a world-leading expert, has to say about it.
There are people who, for reasons I do not fathom, I just literally don't understand their reasons, are so deeply committed to locality that they're looking for any escape route. I mean, that's more or less what we were talking about with these loopholes, with these detection loopholes, right? They don't like the idea of non-locality, and they're looking for any escape they can have from accepting it. And these detection loopholes for many years were one until the experimentalists just closed those loopholes. They're gone. So the only other loophole is they look at this and they say, well, I don't want to deny locality. I guess I have to deny statistical independence. And the problem with denying statistical independence is that it's kind of crazy, and it's crazy and conspiratorial. And on top of it, as you know, I've said and other people have said, it undermines all scientific method. I mean, if in order to get out of accepting non-locality, you deny what's required, assumptions that are required to do science, that's not a good deal, right? That's a really bad deal.
Speaking of that, I sent you a video. I'm unsure if you had a chance to take a look.
I've given 3 different examples in theoretical physics where the world expert outright rejects Sabine's position. Then, what do we make of Dr. Hossenfelder? One thing is sure, we have to be highly skeptical when we hear from one side only, especially when that person is speaking on topics that have no consensus. She is, at the moment, out of academia, and her YouTube videos and books are doing amazing. So, one thing is sure, you will not stop hearing from her. So, love her or hate her, we have to learn to live with her.